Speaker mode.
Good afternoon. We're going to continue today for convolution integral, and I'm planning to make a quick revision for convolution integral because I know you need to focus on it and you need more explanation. And I'll try to make it simple by a couple of examples. And then I will, you will do practice this class to make sure that you understand how to do convolution integral. So focus with me because this topic will be included in the exam, this coming exam on Thursday. So and hopefully I can finish and start convolution sum, how we make convolution with discrete time signal. And if we don't have time, we'll continue next time. But I don't want to take the whole class on Tuesday for convolution sum. It's easy, much easier than convolution integral. It will not take more than half an hour. And then I'll make the rest of the lecture to review some question, like the question I already uploaded the folio with mock exam. And I think you should try to do it after you understand convolution integral. I have very few problems in it, very few, because I know you didn't practice a lot. And hopefully that will have enough time next Tuesday to make some revision for the exam. Okay, let me start with a simple example for convolution integral. We want to understand the meaning of integration if the function is given as expression, mathematical expression, and if it's given like a graph. So how can I deal with both, and can I do it mathematically or not? Because sometimes it's really easy and simple, but we'll think it's complicated. Let me give you one example. And that example, you will see it in the mock exam. And maybe when you look at it, you will just, oh, that's hard, but it's not hard. Let me show you. If you have something like that, I'll start with the simple thing. This problem very similar to what we have. You have evaluate, that's the question, evaluate x t plus 1 convoluted on delta t minus 2. And that's multiple choice. And you got choices like x t minus 1, x t plus 1, xt, xt minus 2. So, and you have these choices. Choose between A, B, C, D. E. Got 5 choices. So to solve this one, it means that we want to find the value of the convolution. Not actually the value, the right expression. You are going to choose the right expression. It means you got to convert the convolution into integral. So the integral, how to do the integral, let me just write here, x t plus 1 convoluted on delta t minus 2. You got 2 choices. The 3 choices, you replace one by t minus tau and the other one tau. Before I do that, I will just refresh your memory. If you want to find the convolution of xt on ht, we said we have 2 ways. It's either from negative to infinity, x t minus tau times h tau delta tau, or h t minus tau x tau. So there is one way change t by tau, and other expression which would change t by t minus tau. Which one? Both are right, but it depends on the problem that you have to make the right choice. In this problem, what do you think? Which one? Consider this is x and that's h. What does it matter? Which one you will exchange it by tau, t by tau, and which one in this problem, the root is t by t minus tau? Because that's what's happening. One is t minus tau and one tau. Which one? And why? Do you like to give you a hint? All right. Now you have one function, delta, impulse, unit impulse. So you got to review, what do you know about impulse? Do you have any specific about the impulse function? Do you know something about the integration of the impulse with any function? Then you have to review what you studied before for the elementary signals. We did the unit impulse. What about the integration of the unit impulse? Okay, and what happened if you want to integrate it and it's multiplied by another function? I'll refresh your memory. If you have any function and multiplied by delta t minus say anything, I don't say tau, minus alpha delta t, if you are integrating with respect to t from negative infinity to infinity, what is the result of this one? It's the function you substitute by t at alpha, right? Again, you just write again. Let me make it simple. An example that we did. Let's say that you have a function and function is equal x squared, all right? X of t squared, and multiplied by delta t minus 1 delta t. What is the value of this function? You said that any function multiplied by delta t minus 1, it will be equal the function substituted by t equal 1, who's shifted by t minus 1. That's what we did, right? So it's important to keep the delta, keep it as it is, t, make it tau. So let's choose this choice. So you will exchange t by tau and exchange t by t minus tau, according to this formula that we have. I'm using this one. All right. So when you do that, you'll have x and t replaced by t minus tau plus 1 as the expression, and delta t will be tau minus 2 delta tau. Remember, you are now integrating with respect to tau. Yes, t is a constant. So how you are going to solve this? Easy. As we said, that will be the function, and that's the delta. So the function will be x t minus tau plus 1, and you substitute by tau. Why I'm saying by tau? Because you are integrating with respect to delta tau. What is the value of tau we're going to do? You look at this one. 2, yeah. Simply you can make this equation equal 0. So it'll be 2. So you go for the expression, you have x t minus tau. Tau is equal to plus 1. So it will be x t minus 1. So the right answer is x t minus 1. The first one. So this one depends on your understanding to the property of the impulse function. Yes.
So this example you showed us uses that first of the two variants of the equation. What would an example look like where we use the second variant of the equation rather than the first variant?
I mean the second, if you want to have h, if you want to have the second one t minus tau, the first one is tau. Okay. We're going to have like 2 examples after that for doing this property. Now let's take how we do the integration if you don't have impulse, you have something else. All right, that's example 2. Actually, it has impulse. Find E minus 2t convoluted on delta t. That's easy, that you can do. The solution for this problem. You are going to say that that will be equal to the integration from negative infinity to infinity, E minus 2t. No, you are going to replace now, since you make the integration, you got to replace t by t minus tau. And delta, we keep it tau, because we have property that help us. According to this integration, that's easy. It will be equal to this function evaluated at tau equals 0. So you have E minus 2t minus tau evaluated at tau equals 0. Because you have delta tau not shifted. That will be equal to E minus 2t minus 0, which is equal to E minus 2t. So the answer will be E minus 2t. If you are asked to find the value of this, find, for example, if the question like that, find this mathematical relation at t equal 3. You have first, don't substitute by t here. No, after you finish, then you will say y3 equal to, if you call this y of t, so y3 will be equal E minus 2t, and you put t equal 3, will be E to the power of negative 6. And using the calculator, you find it's a value. And there are many questions like that. Just if I want you to do the short answer, I will ask you evaluate this or this expression at t equals 3. So you can give just one number. So you got through all the steps. All right. Now, last, I'm going to explain how you do the integration using graph and mathematical expression in a very simple function, using simple function, so you can get it. And will be steps. And these steps, I'm going to use this table. And after I finish this example, I'm going to give every group of 2 members to work on a problem, similar problem to what I'm going to do right now. So you pay attention to this one. We have 2 simple functions. The first one from -1 up to 2. So that's from -1 to 2, and that's the t, and the value is equal to, and that's called h of t. The input signal, it starts from -2 up to 3, and the value is equal to 1.5. And that's x of t. The question is, find xt convoluted on ht. That's y of t. For me?
For x of t, what's that value? -3?
1.5. Let me to do that, it's better to use a table. Let me show you the table, and then I'm going to do it step by step. Yes.
But how far on the left side did it go? Like into the negative?
And -2 up to 3. I'm going to check it now. Let me show you the table, and then I'm going to go back to the example. This sheet it's really nice if you use the sheet when you work a problem like that. And they'll give you one today to work on. And our laboratory system, that's really a big life easy. That's the case of the stage and then the interval from what number to what number, and then the integration limit, then the value of integration, and then you check the endpoints better. I'm going through each one of this table. That will make it really easy. Okay, so that's from -2 up to 3, and this from -1 up to 2. The first thing you do, yes.
What does that say of the H of what?
H of t, just I mean this software has had a problem. Okay, that's H of t.
Oh.
Yeah. And the value 1.5 here, and the value there is 2. The first thing to do, you know, when you do the convolution, you are going to do integration as, and let me just write what's about that. 2 possibilities will say y of t will be equal -infinity to infinity. The integration of x t minus tau h tau d tau, or h t minus tau x tau. Which one you choose? Last lecture, I told you that would be a good choice. To make a good choice, first you got to find the width of each signal. What is the width of this signal? The width is equal 3, right? What is the width of this signal? 5. Which one is shorter? Yeah, the shorter one, you make it t minus tau. Why? Because this one, you're going to slide. So you like to slide small thing inside a big thing. You cannot slide big thing inside small thing. Right? Make sense? Yeah. So since it is shorter, so I'm going to choose this expression. Why I'm going to choose this expression? Because the width of ht smaller than the width of xt. Good. So we want to find the expression of x tau. It's easy. Xt, first you write the expression of xt. Xt equal to 1.5 when t greater than -2 less than 3. Just look at it. That's right. X of t is equal 1.5 from -2 to 3, because behind these two limits it's equal 0. So that's x of t. But I want x of tau. I choose already this expression, so I need x of tau. So I'll say x of tau is equal 1.5 and replace t by tau, so tau from -2 to 3. That's the first expression. Second expression, ht minus tau. I go to the sketch here and I try to find expression for ht first. It's equal to, for t greater than -1, less than 2, right? So greater than equal. So h of t is equal to when t greater than, less than, forgot, -1 to 2. Good. I need to replace t by t minus tau. Go ahead and do it. Just substitution. Say h t minus tau equal to, replace t minus tau. But you want to make the interval only for tau. So you add -t to everything. If you add -t, so it's cancelled, you have only -tau. You add -t to both sides, so -1, -t, 2, -t. You know what I did? I added -t to each term. Why I'm adding -t? To cancel this t, minus t minus tau, to cancel this t. But I want the interval only tau, not -tau. Multiply by -1. When you multiply by -1, what you'll do? You flip the sign of the inequality. So you got -2 plus t and 1 plus t. So you can write it in a nice way. You say h t minus tau is equal to when tau greater than, less than, greater than this one, which is t minus 2, and less than t plus 1, this one. So you got the two expressions.
Those two expressions are highlighted.
There's the two expressions I'm going to use. In this integration, you multiply. So I multiply. So I'll say h t minus tau times x tau will be equal to 2. That's the value for x t minus tau, and x tau equal 1.5. Means 3 over 2. So the answer is 3. So the product is these two functions. Of course, it is a simple function, and that's okay for this example. You don't have to, because sometimes you can find it's defined over 3 periods or 3 intervals. For interval, that's okay, but it's the same concept. But just you focus with me on this one to understand how you divide the interval. Okay. So now I will start to divide the process into stages. The stages like that. First, you have to find the interval of each stage, as explained last lecture, like when it's no overlap, when partial overlap, complete overlap, another overlap, then no overlap again. So there are stages. And there are general stages that any two signals, when you find the convolution of them, you do this. Sometimes it will be simpler, like you have only 3 stages, 2 stages, but this one is general, it has all stages. How can you find the interval? Okay. To find the interval, you look for the limit for the one t minus tau here, xt minus tau. X tau, it's fixed. You don't worry about it. What is the interval of the fixed one? Tau from -2 up to what? 3. This is the fixed one. This is the big one from -2. So let me just show you what you're going to do. That's the old tau axis. And set from -2 to 3. -2 to 3, so that's 0. That's -2. 1, 2, 3. That's 3. So you'll make the you're not making the height or anything like that. Just can make it bigger if you like. You're not. You got to know. I'm not sketching the function. I'm just making the boundary of the region, because maybe this function, by luck, just it's very similar to rectangle. But even if it's triangle, sinusoidal, exponential, I'm not sketching here. I'm trying to find the interval. So this is the interval. You leave it as it is. Don't fill it. Leave it like that. And not to forget, you write what it is. It's x tau. Just remember. The other one, that's the interval. You just do it outside. That's the first thing. It's outside, like far. By how many units? Doesn't matter. But just outside, not touching. So I'll just make it like that here. And the width is 3. So that's the important thing. And fill it like that to distinguish. And that's h t minus tau. Then look for the boundary or of the interval. It's from t minus 2. That's why the expression it's very important. T greater than something, less than something. So greater than something, this is the small one. That will be t minus 2. And this one will be t plus 1. That's the first step that it would be easy. If you do that in the beginning, it'll be easy. What's happening now? We're going to slide this shaded region step by step. First, that's the first case. I call it case A or stage A. No overlap. Then if I ask you, how do you find the interval for no overlap in this diagram here that you see? In other words, can you give me inequality of the time t that will satisfy this stage?
What did you say?
Yeah, you can tell me t less than, greater than, or less than, or greater than, like that. What the value of it that will be valid for this? What's less than -2? That's important.
So,
What's less?
T.
T? No. Exactly. You see, when you look at it, it's very simple. You look for, you only find there are two next to each other. Only, that's what you have. So you're saying that t plus 1 should not reach -2, right? So I'll say t in this case, for case A, t plus 1, this one should be less than -2, not to start any overlap. In this case, it means t less than -3. So I know now t less than -3 will make no overlap, and you don't have to do any integration. And in this case, yt is equal 0, right? So you go for the table. I'll come back again to the same screen, but just I want to show you how you use this table. You go for case A, you write case A, and I know case A no overlap. The interval, it's just we said t -3. So if you wish, you can write like this, from -infinity to -3. If you know how to make it up, but that's okay. The first stop, t less than -3. What is the integration limit? You don't do integration. The value 0. What's ya and yb? That's a and that's b. It's 0 everywhere. That's the first row. Always is really easy. You understand now how you do the table. Now we'll go back for our business here. So no integration. That's the easiest one. Let's go for the second stage. The second stage, I will do the same thing. That's why I keep it here. I will do the same thing. That's the tau axis, and that's -2 up to 3. -1, 0, 1, 2, 3. That's fixed. And as I'm telling you, I'm not sketching the function. I'm just sketching the interval. And now this shaded region, the signal is getting in partially. So I will just do it like that. That's partially. The interesting thing, once you write the limit of this shaded signal, keep them. You don't have to redo it every time. That's t plus 1. That's t plus 1. And this one, t minus 2. That's t minus 2. And now I want to find the interval for case B. Can you get the interval of case B? Case B? Like we did the first stage. So what is the interval that will be valid for partial overlap? Negative. Yeah, negative. That's right. You see, -2 has to be between, means greater than t minus 2 and less than t plus 1. That's good. And then you continue from here, you'll get the both limit. You will say this side, you have t minus 2 less than -2. So what's t less than 0, right? When you go for the second part, -2 less than t, so t plus 1 is greater than -2. So t greater than -1, -3, right? So in this case, for partial, or case B, for partial overlap, t is greater than -3 and less than 0. So you can write just in one expression, it's greater than -3 and less than 0. From -3 to 0. I will go, and you will go to the table. and you write stage B, t greater than -3 less than 0. You can make it like that if you wish. So that's your A and B. There is integration limit. You want to know the integration limit? Let me go back. Then you tell me the integration limit different than the interval? Yes. When you want to integrate, you integrate only the common. It's only overlapping only in this region, not all of it, right? So the integration should be from what to what? Excellent, from -2, because when you see that this value, whatever the value, I don't care, there will be 0 here. So from -2 up to t plus 1. That's right. -2 t plus 1. So we'll go to the table, -2 to t plus 1. If you organize your solution in this way, you will never do a mistake. It'll be easy. Now I want to do the integration. So I will say y of t equal the integration from -2 t plus 1. Remember, we already multiplied both functions. Let me show you to remind you. Multiply them in the beginning. We found that the product is equal to 3. When I multiply h t minus tau, x tau that I want to integrate it as we agreed before, that's the expression, I found it's equal 3. It's simple. I mean, sometimes you have expression, but just the objective of this example is show the steps. So it's equal 3, the product, everything. I'm integrating with respect to tau. And do the integration. It's very simple with 3 and then tau. And the limit from t plus 1 to -2. Let me save your time, give you the result. I got it equal 3, t plus 3, the integration. So I will go in the table, and this is the limit of integration. I did the integration. I got the value is equal 3, t plus 3. And now you got to find ya and yb. I mean the value of this function, the result of integration, at the end of the interval. 1 time -3, that's your a. If you put t equal -3, -3 plus 3 is equal 0 times 3 is equal 0. Now find b. b is equal 0. Put 0 at t, t equals 0. 0 plus 3 is equal 3 times 3 is equal 9. Remember, you always find this equal this. The end of the previous interval, the value at the end of previous interval should be equal to the value of the beginning of the interval. Yes. Why? Let me see. Let me check it. Maybe there's an error integration. But you forgot something when you make that 3. T will be t plus 1 minus the value of this one, which is equal to -2. Minus will be positive. Fine. All right. So I'll go back to the table, just see what we did. And you check that this value YB of the previous one equal to the one. That's great. Now let's go for case. Yes. YB, B is equal 0 here. What 0 plus 3 is equal 3. 3 times 3 is equal 9. That's your B, that's your A. Any question? Let's move to the second stage. All right. Or the third stage. Here we did this one. Now the third stage is slide this shaded region more so to be completely involved or overlap there. Remember this from -3 to 3 fixed. You don't move it. I'm moving only this other one, smaller one. So from -2 to 3, just let's do that tau axis. And from -2 to 3, okay. Then you have -5. All right. And the other one will be completely inside. So I'm keeping the limit. I don't change this from -2 to 3. And by the way, this never changed. It was t plus 1, I think. And that was t, t what? -2. -2, that's right. And now we can make the whole thing overlap. All right. What I'm trying to do, find the interval. How you find the interval? You have relation between this and relation between that and that, right? What is the relation between -2 and t minus 2? T minus 2 is bigger, as you see, right? Exceeding. So I'll say t minus 2 is bigger than -2. So t is greater than what? 0? Oh, okay. And this one, you have relation between t plus 1 and 3. T plus 1 is less than 3, so t less than 2. So you got t is greater than what? 0 and less than 2. So from 0 to 2, that's the case. I will go before I forget, 0 to 2. I go to the table. So from 0 up to 2, or you can say t greater than 0, less than 2. Observe that b from -3 to 0 and this 0 to 2 is always continuous like that. All right. Let's now go for the integration limit. When you integrate for case C, what is the limit? Exactly, because it's all inside. On the inside, t minus 2 up to t plus 1. Because there are values between these two limits. There is no zeros. The only thing when I cut the boundary or the limit of integration, when there is something will be equal 0, the value of the function, one of the function will be equal 0. So from t negative 2 to t plus 1, that's the first. Oh, so let me just do that. Integration from t negative 2 to t plus 1. All right. Now I'll do the integration. That's easy integration. Because the function, intentionally I make it easy. So y of t will be equal to the integration from t negative 2 to t plus 1, and the value is equal 3 d tau. I did that, I found z equal 9. I found the t's cancel when I after integrate, equal 9. So I go and I would say the value of integration is equal 9. So ya is equal 9 and yb is equal 9 at the boundaries. It's just straight line. And let me check, they are equal. I'm fine. And you can integrate it by yourself. It's very easy. B3 tau, this of tau t plus 1 minus t plus 2. So the t cancel, as you see, and then all numbers add. Then now we have the other stage. Do you have any question in this stage? All of them the same. If you follow this systematic, we'll go now for the other stage. And also start from -2. And start to overlap, but some part getting out. We keep this limit the same. That's -2, and that's 3. And this t plus 1, t -2. You see, the first limit that we did it, very important. Once you get it right, if you did an error in one, just the rest will be wrong. So be careful about the first step. Now let's just try to find the limit. How you find the limit? There is a relationship between this number and this number, right? T minus 2, t minus 2. There's relationship here and also there's relationship there, right? There are two. So when that 3 is like the first case, 3 is between t plus 1 and that, let me write, 3 is between, 3 is bigger than t minus 2, but smaller than t plus 1. And then we'll divide it into two parts, like we did the first time. t minus 2 less than 3, so t less than 5. That's 1. And the second one, you have t plus 1 greater than 3. So t greater than 3 minus 1 is equal to. So t greater than 2 less than 5. So let me write t greater than 2 less than 5. If you are not convinced, ask me and they'll do it again. I always just look at the numbers, look at the thing and see the boundary around and find this relation. Just very easy. So it's from 2 to 5. I'll go to the table, 2 to 5. That's D from 2 to 5. And I feel it's right because when I do the calculation, I find this number like this number. See, this number like, so I'm on the right track. Or you can write t greater than 2 less than 5. Now I want to find the limit of integration. The limit of integration, it depends on the shaded region only, the overlap region. So somebody can tell me what the limit of integration in this case? From t minus 2 up to? That's right. Right. Excellent. So you will say y of t is equal to integration from t minus 2 up to 3 d tau. And I got it equal 3 times 5 minus t. That's the value of the integration, the result of the integration. 3 times 5 minus t. I will go in the table and I'll put the result. Oh, the limit we said that it's from t minus 2 up to 3. And the integration we got it 3 times 5 minus t. Now I try to find ya and yb because this is another check. I put a equal to 2 from this interval. So 5 minus 2 is equal 3. 3 times 3 is equal 9. That's good. Why? Because it should be equal to the previous one, right? When I put b is equal 5. 5 minus 5 is equal 0 times 3 is equal 0. And I get good feeling because I know after that will be no overlap, will be 0. Because it'll be out. Let me show you. Here, after this stage, what's next? The old signal will get out. But you have to do to get the interval to make sure that our work is right. So you go there, and that's down, -2. Up to 3. And is out. T plus 1, t minus 2. Obviously, you can find only one relation because this number is just next to one limit, not the other one, right? So from this, 3 is less than t minus 2. So you add 2, so t greater than 5. So after 5, no overlap is equal 0. So you go there and you'll say, oh, that's right. It's from 5 up to infinity. Or you can say t greater than 5. No integration. The value is 0. 0. That's right. And of course, we can sketch now this function, the whole y of t, and get how it looked like. Well, how you divide it according to the interval. So you remember these points. You got -3, that's 1 point. You got 0, you got 2, you got 5. So these points, keep in mind, the all bound is -3 and 0, 2, 5. So I will go to have a sketch of the result. But the question now, the x-axis, is it t or tau? Tau? Okay, let me show you the table. I will show you the table. But you are convinced about this table, right? So what is that? Y of t, yes. So when you sketch y, the result, that will be t. And That's the y-axis. The first thing was 0 when it was t less than -3. So you have that's -3. That will be 0. And 0 again when t greater than 5. So 0, 1, 2, 3, 4, 5. From that will be 5. Within the 0. Now we'll go for the first region that those overlap from -3. Let me write the expression that we discovered. From -3 to that's -3, and that's 5. From -3 up to 0, the function we found y of t equal to 3t plus 3. You can say it's equal 3t plus 9. So at -3 we have 0. That's good. And the limit up to 0 at 0 would be 9. So just let's consider this is 9. I don't have enough space, so it's straight line up to here. I go for the second interval, and that's from 0 to 2. The function y of t was equal to 9. So from 0 up to 2, it will be just fixed. Equal 9. I'm sketching I'm sorry, not y of t. 9. And from 2 to 5, the function y of t is equal to 3 times 5 minus t. So the end at 5 will be actually 0. So the straight line, that's easy. And after that will be 0 as you see here. So that's the response of y of t. And once you sketch it, even before you sketch it, let's say that the question asks you find y3, y of t when t equal 3. So if you are asked to find y3, you have to look for the interval and substitute by the right equation. That's one. If you don't have to sketch it at all. So 3, it's in this region between 2 and 5. So use this equation. So we'll say y3 is equal to 3, 5 minus 3. I put here t equal 3. So you will have 5 times 2, it's equal 10. Oh no, 2, 6, I'm sorry. That's not 5, it's 3. Yeah. It can't be 10 because I mean the maximum is 9. So that's another thing. When you get all values, then so the value is equal 6. So if you are asked question for only finding the value of the output at specific time, you don't have to do the whole thing. You just do only the interval that asked for. That's another thing. Because that's the mistake I did when I was a student. I was doing the whole assignment, but when I go to the exam, I never finish it and I get low grade. And then after 2 times, I said, no, I got to talk to the professor. I said, I'm doing everything. I'm doing the assignment, the homework, and then I come in the exam and the quiz. I never finish. I finished only 60%, and I know every single problem. When you look at my paper, I found that it told me you are very honest in solving the exercise. You should not be very honest. If I ask you to find the value of y of 3, you will only do the interval that's 3, because you can do it. To do one interval does not depend on other, right? So keep in mind this. Now I want to make sure that you understand and can do it by yourself. Let me see if I have time. 1:25. We have time, right? Finish it. We have 20 minutes, right? Will not take more than 10 coming. That's right, 45. Let me just sketch for you the problem that you're going to do, and then I'll give, to save the time, just if somebody can help me. Everybody gets one sheet. Every group, I'm sorry. So everybody pick your partner. 2. Every 2. You have to work together. Yes. That's the first thing. And then every group take only one sheet. Yes.
One sheet per group?
Yeah.
One per group, yes. For me? Okay, okay.
Oh, yeah.
Oh, thank you. That's h of t. It starts from 0 up to 4. And this equation for x of t that's equal 1 from -1 to 1. That's x of t. The question is, I wanted to do the same process xt conjugated on ht. So try to, yeah. So you look for the weight container and make the same steps.